Hello students, welcome to mathematics class. Students, this is part 5 of the chapter mensuration. In this part 5, we will revise the questions from the exercise 11.2. Coming to the exercise 11.2, it has got 11 questions. We will solve one by one. Question number 1. The shape of the top surface of a table is trapezium. Here is the figure. So, find its area if its parallel sides are 1 meter and 1.2 meter. 1 meter and 1.2 meter. And the perpendicular distance between those two parallel sides is 0.8 meter. Children, you know the formula to find the area of a trapezium. Area of a trapezium is found using the formula half into height into the sum of two parallel sides, that is A plus B, where A and B are parallel sides. Here in this question, A is given as 1 meter, B is given as 1.2 meter, as well as height is given as 0.8 meter. Therefore, on substitution, we get half into 0.8 into sum of 1 and 1.2. So, on simplification, this 2 cancels with 0.8, gives you 0.4 into 2.2 gives us here 0.88 meter square as the area of trapezium. Children, we have conversion from meter square into centimeter square. That also let me explain you with this example. So, area of this trapezium is 0.88 meter square. 0.88 meter square. If you want to convert it into centimeter square, you know 1 meter is 100 centimeter. Further, if I square on both sides, square on both the sides, that means I have to take 1 meter whole square is equals to 100 centimeter whole square. It gives us 1 meter whole square as 1 into 1 is 1, meter into meter becomes meter square, implies 100 into 100 becomes 10,000, and we have centimeter square becoming square centimeter. So, for 1 meter conversion into centimeter is 10,000 centimeter. So, if you want to convert this 0.88 meter square into centimeter square, you need to multiply it by 10,000, which gives you 8,800 centimeter square. So, this is the solution of this question. Moving on to the next question. Question number 2. The area of a trapezium is 34 centimeters square and the length of one of the parallel sides is 10 centimeter and the height is 4 centimeter. Find the length of the other parallel sides. So in this question, area of trapezium is given. So we will equate this 34 centimeter square half into h into a plus b equals to 34, where we are given that one of the parallel sides has 10 centimeter and the other we don't know, height as 4 centimeter. Substituting them, half into 4 into 10 plus, let us say b, we don't know, I am keeping it as it is b. So on simplification, 2 2s are 4. So this 2 which is multiplying here, if it comes this side, it divides. So 34 divided by 2 gives you 17. So b plus 10 equals to 17, and this addition or this addend transpose the other side becomes subtrahend. So 17 minus 10, thus the other side is 7 centimeter. You can write conclusion. This is how we solve this question. Moving on to the third question. Question number 3. Length of the fence of a trapezium shaped field ABCD, here is the figure, is 120 centimeter. What is the meaning of this? Length of the fence of a trapezium shaped ABCD. That means, children, hint is here, the fence is always perimeter. Perimeter is given to us. So perimeter of ABCD is 120 meter. You know how to find, we need to find AB plus BC, sorry, it is plus BC. Let me write properly. Here AB side plus BC side plus CD side plus DA side put together gives you 120 meter. But whereas BC side is of 48 meter and CD is of 17 meter and DA is of 40 meter. On substituting them, which we don't know, we'll get AB length we don't know. Here AB we are keeping as it is by substituting those BC length as 48, CD as 17, DA as 40 which is given equals to 120. Now this sum 48 plus 17 is 65, 65 plus 40 is 105, 105 which is addend if it is transposed the other side becomes subtrahend. So 120 minus 105 gives us AB length as 15 meter. The moment you got 15 meter, you watch here, angle ABC is given 90 degrees. Therefore, AB is perpendicular to BC. You know, AB is perpendicular to BC, and we already said that it is a trapezium. Since AD parallel to BC. Why? Because in ABCD trapezium, these two are only parallel sides. Now we got H 15 meter, A parallel sides 40 meter and B 48 meter. Therefore, area of this trapezium is half into height into sum of the parallel sides. Thus, half into 15 into 40 plus 48. 40 plus 48 is 88. 88 by 2 is 44. 15 into 44. On simplification, you will get the answer as 660 meter square as the area of this trapezium. Then moving on to the further question number 4. In question number 4, the diagonal of a quadrilateral shaped field is 24 meter. Here is the figure first. And the perpendiculars dropped on it. Here we know diagonal is of 24 meter. Let us say A, B, C. In this quadrilateral ABCD, diagonal AC is 24 meter and the opposite vertices B and D, from them perpendiculars dropped are given of 13 meter and 8 meter. You know, in this question we call them as height H1 13 meter, height H2 8 meter and diagonal D is of 24 meter. So we have learned the formula as area of a quadrilateral is half of the sum of the perpendiculars dropped from the opposite vertices of a diagonal and the length of the diagonal. So that is half of H1 plus H2 into D. Now by substituting those, half into 13 plus 8 into 24. So this 2 cancels with 24, gives us 12, and 13 plus 8 is 21. On simplification, you will get the product as 252 meter square as the area of this quadrilateral. Okay children, this is how we find. Coming to the next question, question number 5. The diagonals of a rhombus 7.5 centimeter and 12 centimeter. Find its area. You know children, area of a rhombus is found using its diagonals. So rhombus, half of the product of diagonals is the area of the rhombus. Here in this question, D1 is 7.5 centimeter, D2 is 12 centimeter. On substitution, half into 7.5 into 12 gives us the product as 24 centimeter square. Sorry, not 24, it is 45. Product, let me erase it children. Here 2 and half get cancels. 2 under this half and 12 get simplified as 6. 7 and a half 6. 7 and a half 6 is 7 and a half twice is 15. 15 thrice is 45. So it's a 45 centimeter square. Moving on to the next question, question number 6. In question number 6, find the area of a rhombus whose side is 6 centimeter and whose altitude is 4 centimeter. So children, here we have rhombus where all sides are equal and we don't know what is the diagonal length. Here 6 centimeter is the length of each side of that rhombus, and we are asked to find the length of the diagonal where one of the diagonals is known to us. One of the diagonal is of 8 centimeter. Okay, let's say this is 8 centimeter diagonal, and we don't know what is the another diagonal. To find another diagonal with the help of d1 into d2, I should know area of it, correct? So area of a rhombus we need to find. How to find area of a rhombus? Every rhombus is a trapezium. So I am taking the formula to find area of rhombus with the help of formula to find the area of a rhombus as area of trapezium. Here corresponding height is given to us. That means distance between two parallel sides is known. This side is 6 centimeter and the other side is also 6 centimeter, and the distance between them as 4 centimeter given to us. Therefore, every rhombus being a trapezium, area of this rhombus is half of sum of the parallel sides, that is 6 plus 6 into that corresponding height 4. Now it becomes 2 to the 6 plus 6 is 12, 12 to the 24 centimeter square is the area of this rhombus. Now by equating this 24 to the half of, where d1 is known to us 8 and we don't know other diagonal, let's say d2 only, so 2 cancels with this 8 as 4, and 4 is multiplicand. If it comes this side, it divides 24, so 24 divided by 4 is the other diagonal. Therefore the other diagonal is 6 centimeter. This is how we find the other diagonal here. Okay, so moving on to the next question, question number 7. Question number 7. The floor of a building consists of 300 tiles which are rhombus shaped, and each its diagonals are 45 centimeter and 30 centimeter. So we know diagonals already, that means we can find area of it. So find the total cost of polishing the floor if the cost per meter square is rupees 4. Children, here 300 tiles are there in that floor, but I know only the diagonal of one of the rhombus. That means first we will find area of one tile, that is one rhombus shaped tile, okay, which is half d1 into d2. So half into 45 into 30, on multiplication we will get 675 centimeter square as the area of one tile. But to find the area of the whole floor, we need to multiply 3000 times of this area of the one floor. So 3000 into 675 centimeter square will be the area of the floor. So on multiplication it becomes 20,25,000 centimeter square. You know 1 meter square is of 10,000 centimeter square. So on reverse we get 1 centimeter square is 1 upon 10,000 meter square. So by unitary method, this can be converted into meter square by dividing this 20 lakh 25,000 with the number 10,000. So these three zeros will get cancelled and 2025 by 10 becomes 202.5 meter square. Now this is the area of the floor in meter squares. Now cost of polishing. So cost of polishing that floor at rupees 4 per meter square will be, for 1 meter square rupees 4, for 202.5 meter square to be multiplied by 4. So this much rupees. So on product, on multiplying this, it becomes rupees 810 rupees as the cost of polishing that floor. Children, with this question, our video has become 21 minutes 30 seconds. I'll wind up. Rest of the questions I'll carry on in next class. Okay. See children, this video you have watched or you are going to watch on 15th of February. Okay. Till then, take care of yourself. Jai Hind. Thank you.